All right, so today we're doing something a little different. We're not going to debate some wild new theory about the universe. Instead, we're going to pull back the curtain and look at the scientific audit. That's the really tough, methodical process that takes a cool idea and figures out if it's actually real science.
So you might be asking, why do we even need new ideas in the first place? Well, it's because our best theories, the ones that have been proven right time and time again, like the Standard Model and general relativity, they're amazing, but they're not perfect. They've got cracks, unanswered questions that basically leave the door wide open for a new perspective to walk in.
And that's the big question, isn't it? If you think you've got a game-changing idea, how in the world do you challenge these absolute titans of scientific thought? It's not enough to just say, hey, I've got a cool idea. You have to prove it. But how?
Well, it turns out there is a process, a kind of scientific gauntlet, you could say, that every new theory has to run through to be taken seriously. It's a structured journey that goes from pure idea to actual validated science.
Because in the world of serious physics, you can't just wing it. There has to be a framework. This whole system makes sure that an idea is tested on its own merits, not on who came up with it or how famous they are. It's all about the work.
So what does this gauntlet actually look like? Well, it's these 6 tasks of scientific inquiry. You start with a clear concept. Then you have to translate that idea into hard math. From there, you figure out how to model it, how to prove it, and then you design the specific tests. Only after all that do you actually build the experiment and run the numbers. And here's the kicker. You can't skip a step. Each one has to be done before you can move to the next.
But here's the thing. Before you even start step 1, there's this core philosophy you have to buy into, what's called conceptual grounding. And it really just boils down to humility. You have to admit from the very beginning that your theory has limits.
I mean, listen to that, be humble. In a field where you sometimes get these huge, grand claims about knowing the mind of God or the origin of the universe, this framework demands the complete opposite. It's a recognition that what we're doing is, at its heart, engineering. And engineering is always about approximation.
Okay, so this all sounds a bit abstract, right? Let's make it real. We're going to look at a case study, a research program that calls itself the New Perspective. It's a pretty radical idea, and it's actually going through this exact 6-step process right now. So we're getting a look at a scientific audit in real time.
So where is this new perspective at right now? Well, on the one hand, it's got its conceptual description for quantum mechanics totally nailed down. That's a huge win. But when you look at the Standard Model and general relativity, it's a different story. The ideas there are more like suggested research directions. They're not fully baked yet.
And this right here is where the audit really starts to dig in. We're going to use our 6-task framework to find the exact spot where this promising new idea is getting stuck. So, what's the bottleneck?
And boom, this matrix just lays it all out, plain as day. Look at task 1, the conceptual description. It's still in progress. And because of that one thing, it's created a critical stall. You can see how everything else, task 2, 3, 4, 5, and 6, is marked pending. The whole process is completely blocked until task 1 gets finished.
And this is the key takeaway. The entire scientific testing cycle is just stopped, dead in its tracks. No math can be done, no models can be built, no tests can be run, all because that initial conceptual work isn't 100% complete.
Okay, but a good audit doesn't just point out what's broken, it tells you how to fix it. So now that we've found the stall, what's the way forward?
This is the million-dollar question for any research program that's trying something new, right? Especially when you're on what the source material calls a lonely road, way off the beaten path of mainstream science. How do you get unstuck from a fundamental roadblock like this?
The answer the audit comes up with is something called a virtual numeric reality, or a VNR. Now, don't just think of this as some simple computer simulation. It's way more than that. Think of it like a flight simulator for the universe. It's a complete digital laboratory built from the ground up to see if this new model actually behaves like the real world. And this isn't just a nice-to-have. The audit is basically saying this is non-negotiable. The VNR is the only way to build a bridge from these cool abstract ideas in task 1 over to the cold, hard numerical proof you need in the later stages. Without it, the theory is stuck as pure speculation. So this gives us a really clear roadmap. The audit lays it out, step by step. First, you've got to finish that conceptual work for the Standard Model and GR. Then, focus on building the numerical guts of the thing. Next, actually engineer the VNR software. And finally, figure out exactly how you're going to compare the results from your digital lab to real-world experiments.
So, after putting this new idea through the scientific gauntlet, after this whole rigorous process, what's the final verdict from the audit?
The conclusion is simple and direct. The new perspective is promising. It really does have potential. But, and this is a big but, until it builds that VNMR and its results are tested against reality, it's just an unvalidated theory. It's an idea that's been successfully created, but it hasn't yet been scientifically tested.
And this really brings us full circle, back to the whole point of the scientific method. The potential is definitely there, but whether this succeeds has absolutely nothing to do with who came up with it. It all comes down to the work itself, to methodically checking off those 6 tasks and proving it has merit.
And you know, that leaves us with a really fascinating thought. We love to think of scientific breakthroughs as these big eureka moments. But maybe this is what the beginning of a real revolution looks like. Not a sudden flash of genius, but a lonely road, a frustrating stall, and a super rigorous methodical plan to just inch science forward.